The modern Middle East is defined by stark contrasts. You have towering skyscrapers and immense wealth, sitting right alongside massive slums and decades of regional conflict. Those extremes are driven by one specific resource. The countries of this region hold the largest concentrated reserves of crude oil on the planet. From global fuel prices to international diplomacy, the modern world is anchored by the extraction of this single geological resource from this exact patch of land. There is a common misconception about how that oil got there. It isn't the remains of dinosaurs or land plants. It formed almost entirely from microscopic marine organisms, plankton and algae that lived in the ocean. But that creates a contradiction. Crude oil requires an environment of massive amounts of dead marine life, yet we find these reserves beneath a waterless, sun-baked desert. We have to explain how an ancient ocean's worth of marine biology ended up buried deep beneath some of the driest land on Earth. 100 million years ago, the land that makes up the modern Middle East was entirely underwater. It was the floor of a nutrient-dense body of water called the Tethys Sea. Ancient river systems continually flowed into the Tethys, carrying rich minerals that fueled massive, dense blooms of microscopic plankton. When these organisms died, they sank to the bottom. For oil to form, they had to be buried quickly. Deep tectonic rift basins on the seafloor acted as traps, instantly covering the organic material with thick layers of sediment. These deep basins had very little water circulation, creating an environment with almost no oxygen. This stopped bacteria from breaking down the dead organisms, keeping the organic layers preserved. Over millions of years, the weight of the sediment above drove up the pressure. Combined with intense heat from deep inside the Earth, it slowly baked that trapped organic material into crude oil. These massive reserves exist today because the Tethys Sea provided a rare sequence of rapid burial and extreme preservation that most other ancient oceans lacked. But the oil was still locked beneath an ocean floor. To bring it to the surface, the continents themselves had to move. The Earth's surface is divided into massive tectonic plates that float on a restless, hot interior. These plates shift just centimeters a year, but over time, those movements are massive. Eventually, the Arabian plate collided with the Eurasian plate. That collision forced the land upward. The ancient, oil-rich seafloor of the Tethys Sea was thrust above sea level, pushing those buried reserves toward the surface. We see the same power in the Himalayas, which were pushed to their current heights by the exact same tectonic forces nearby. Over time, this newly raised land dried out, transforming into the deserts we see today, and bringing the deep-sea oil reserves within our reach. The desert didn't create the oil. Continental drift simply took an ancient, baked ocean floor and pushed it up into the sun. That buried black gold is now the primary driver of the region's global power and the center of its long-standing instability. But there is a massive disparity in the timing. It took 100 million years for the Earth to cook this resource, and we are consuming it at a relentless speed. No matter how vast the reserves are, they are finite. Every barrel pulled from the ground is a piece of that ancient ocean that cannot be replaced. Our reliance on this one geographic anomaly has left global economies vulnerable and has directly altered the chemistry of our atmosphere. Mounting environmental costs and a shrinking supply of fossil fuels are driving a shift toward new energy sources, moving away from the buried legacy of the Tethys Sea. We are turning to renewable systems, solar power from sunlight, geothermal energy from the Earth's heat, and wind power. This transition lowers greenhouse gas emissions and reduces the air and water pollution that has impacted human health for a century. Moving away from fossil fuels means finally leaving that ancient ocean floor behind and building a future powered by the living planet above.